In this video, we will see why transformers work only on AC and not on DC. So, as we know that there are two types of current. One is AC and second is DC. AC stands for alternating current and DC stands for direct current. So, have you ever asked yourself why can't we use a transformer with DC? Why does it only work with AC? This is one of the most common questions in electrical engineering. So, let's break it down in a very simple way. So, first of all, a transformer is a device that transforms electrical energy from one coil to another without touching, and it works using a law called Faraday's law of electromagnetic induction. This law says whenever a magnetic field around a coil changes, a voltage is produced in another nearby coil. So it is something like this. Suppose this is one coil, and if we connect this to a DC, let's say, or if we connect this to a supply AC, because if we what will happen if we connect it to DC? So DC is just a straight line like this, and AC is like this. It have a changing magnetic field. It is changing. It is a changing. It have changing magnitude. That means its magnitude changes continuously. So it can produce changing magnetic field. Now here, if we add one more coil here like this, so now what will happen due to mutual coupling? This coil also produces an EMF. So here this shows a deflection. Now let's say this is AC. Now here this will show deflection. Now why this is happening? This is because of Faraday's law of electromagnetic induction. So whenever magnetic field around a coil changes, a voltage is produced in another nearby coil. This is the basic principle that makes a transformer work. Now AC alternating current keeps changing its direction and value again and again. As we have already seen that AC changes its direction and magnitude again and again. So because it keeps changing, it produces a changing magnetic field around the primary coil. So this is the primary coil. This will be the primary coil on which side we have applied the supply, and this will be the secondary coil. So and this changing magnetic field induces voltage in the secondary coil. This is how AC allows the transformer to work very efficiently. Now next question is why DC doesn't work? So on the other hand, DC, that is direct current, flows in only one direction and its value stays constant. Now if the current is not changing, the magnetic field will also stay constant. And as per Faraday's law, if the magnetic field is not changing, then no voltage is induced in the secondary coil. So in simple words, DC, no change, no induced voltage, and transformer does not work. And here is something important: if you connect pure DC to a transformer, it might actually burn. So it is very dangerous. So you should not connect DC to the transformer, because DC flows continuously through the coil. It can cause overheating, damage insulation, and destroy the transformer over time. So now you know why transformers made for AC, because AC changes, and because of that changing magnetic field is produced, and because of that voltage is induced, and DC is steady, so there is no change, and there will be that's why the transformer will not work.